Percentage composition. So let's look at it. Law of definite proportion. The elements in a chemical compound are always present in the same proportions by mass. So it's always going to be, So if we look at, if I'm asking you for 1 mole of oxygen, right? You're going to look at the molar mass, and we know that molar mass is in grams per mole. So if I asked you to collect 1 mole of oxygen, how much oxygen am I asking you for? Right? No. In terms of mass. Right? How many grams, right? So how many grams is 1 mole of oxygen? No, you can just look at it.
Oh yeah, 16.
16, right? So 16 grams is equal to 1 mole of oxygen. So, now, mass of an element in a compound expressed as a percent of a total mass of the compound is the element's mass percent. Okay? So, it might seem like a tongue twister, but we'll worry about it in terms of the actual calculations and the steps that we use to calculate percentage composition. Now, for the chemical formula of water, H2O, the mass percent of hydrogen is 11.2%, and the mass percent of oxygen in water is always 88.8%. Okay, so here is the calculation. It's already been given to you. So when going through the steps, we found that there was 88.8% is comprised of of oxygen, and 11.2% is comprised of hydrogen. Okay, in a molecule of water. So, percentage composition. CO2 and CO both contain the same elements but have different proportions of these elements. Okay. So once you find the percentage composition of carbon in one type of molecule, doesn't mean it's going to have the same percentage in all of them. Okay, they'll always vary. So composition of a compound can be found in a number of ways. How many moles of each element make up a mole of a compound, and describe the percent mass of each element in a compound. Okay. It'll all make, like I said, make a little more sense when we go through some of the calculations. Okay, so just a little bit of the theory aspect. Okay. So the percentage composition of a compound refers to the relative mass of each element. Okay, so we take how much do we have of the actual atom, we look at how much is it in 1 mole of the atom, and we calculate the percentage within that compound. So a compound's percentage composition can be a valuable tool to identify the formula of an unknown compound. So if you were given a compound and you were able to find out what percentage of the various atoms are found within it, you can actually figure out what the formula of that compound is using these kind of calculations. So, let's look at the first sample problem. A compound with a mass of 48.72 grams. Okay, so we have a compound of it. Within this compound, it's made up of the following 2 atoms, or elements, zinc and sulfur. How much zinc we have? Well, 32.69 grams of it is zinc. 16.09 grams of it is sulfur. What is the percentage composition of this compound? So what you want to do is you take pretty much how much you have of zinc and you divide it by the total mass.
Oh, it's like getting your mark.
Exactly, just like getting your mark. Right? So, mass percent of zinc is the mass of zinc divided by the mass of the whole compound times 100. So, to find the mass of sulfur, same thing. Take the mass of sulfur and divide it by the actual mass of the compound. So, here are the calculations. So, what is the mass of zinc? What is the mass of zinc? 32.69. Okay, 32.69 grams. Divided by, what's the total mass? 48.7. Oops. 72 grams, right? So we divide those two, and we get a percentage, and then we multiply it by 100 to actually get it in percent form. And what is the percent form?
67.097.
Okay, so 67.097. 0.097, so 67.1,
10.
right? 1, and we out, so it'll be 10, okay, percent. Okay, so do you guys see why it's 10? Okay, what was it originally? It was 67.097, right? We want how many significant digits? 4. So we take these 4. We look at this one, and these are the tricky ones, right? Because this 9 becomes 10, right? So we carry the 1, so it becomes 67.1. But how many significant digits is that? 3. So what do? I'm able to just add a 0. Okay. Percent. So what we can do is just subtract 100, right? Minus 67.10 to find the other percentage. But what we're going to do is we're actually going to calculate it. Okay, so we're going to calculate it here. So we've got 16.03 grams of sulfur divided by 48.72 grams. Now notice what my units are, percent, right? Because grams cancel out. Times 100. And what do we get? Print 32.90. Or were there any?
902.
Okay, we'll do that many. Okay. So we need how many significant digits? 4. So we take those 2, and we get 32.90%. Okay. So in the end, well, we have 67.10% zinc, and we have 32.90% of sulfur. Calculating percentage composition from a chemical formula. So we're going to find the percentage composition of cinnamaldehyde. Okay, C9H8O. If you assume that you have 1 mole of a compound, you can use the molar mass of the compound with its chemical formula to calculate its percentage composition. So let's look at it in problem form. So we have C9H8O is responsible for the characteristic odor of cinnamon. Determine the percentage composition of cinnamaldehyde by calculating the mass percents of carbon, hydrogen, and oxygen. Okay? So first, right, we don't have any information here. Right? We don't have it. So we need to go where? Where do you think we're going to need to go? Where do we always go in chemistry? Periodic table. Okay. So we're going to go to the periodic table. And we're going to get the following. We're going to get the molar mass of 1 mole. Okay. So we're going to get the mass of 1 mole of each one of these compounds. Right. So what do we have? Well, we have C9H8O. So let's find for carbon. Okay. So we know that we have how many carbons? 9. So 9 times 12.01 grams per mole. Okay. Then we're going to do the same thing for hydrogen. And we have how many hydrogens? 8 times 1.01 grams per mole. Okay. And then, I'm going to try to find that. And then we're going to find oxygen. And we have 1 oxygen, so that 1 oxygen is represented by 16.00 grams per mole. Okay. So take a moment, find those numbers. What do we get here for carbon when we multiply 9 times 12.01? 108.09. What do we get? And it's grams per mole, or even just grams. What do we get for hydrogen? 0.08 grams. Okay. Now, how much of this do we have? What is the mass of this total compound? of cinnamaldehyde.
132.7.
Okay, so total mass. Okay. So the total amount, what was it? 132.17
32.17.
grams. So what do you think we're going to do to find out the percentage of each and every single one of those elements?
Divide those numbers.
Exactly. So we're going to do carbon. Okay. So we're going to take carbon, the 108.09, and we're going to divide it by this total. Okay. And we're going to divide all of these by that total. So 108.09 divided by 132.17 grams. And then we're going to multiply it by 100. When I don't have significant digits in the question, always round off to 2 decimal places. Okay. So that will be for carbon. Then for hydrogen, we have 8.08 grams divided by 132.17 grams, and we're going to multiply that by 100. So we use red, use green for carbon, and let's use black for oxygen. So 16.00 grams divided by 132.17 grams times 100. 81.78. When we divided now the hydrogens, what did we get? Percent. And lastly, when we divided the oxygens, what did we get? 12.11%. And then what you can do to double check, make sure that you're correct, what can you do? Add them all up. Okay. Add this, this, and this. What should you get? 100%.